The last section in this chapter is on symmetry, and this is actually a nice section because symmetry is something we've known even since we were little kids. You've known when something is symmetrical, when it's balanced. We've already talked about line symmetry. I wrote the definition for you. Line symmetry is when a shape is reflected over a line and it maps onto itself, or it's exactly the same. So here would be a line of symmetry. Different triangles have different lines of symmetry. Like that was an isosceles triangle, it only had one line of symmetry. This looks like an equilateral triangle that actually has 3 lines of symmetry, one through each corner, and you have to draw all 3. We've done the lines of symmetry in the square before, right? It has 2 lines of symmetry that kind of make a plus sign, and then 2 lines of symmetry that go through the corners. This hexagon will have, I believe, 6 lines of symmetry, right? Through each corner, through each thing here. I think I can go here and here. Am I missing any? I think here and here. Yeah, I think there's 6 altogether. Does there have to be lines of symmetry? I don't think that one has any lines of symmetry. Could there be? How many in a circle? Getting sloppy here because I know the answer. Oops. How many lines of symmetry in a circle? Right, infinite lines of symmetry. So that's line symmetry. We already knew that. And then we have point symmetry. Point symmetry is when you turn a shape upside down, aka rotate it 180 degrees, and it stays the same. So I usually have this point drawn in where we got to turn the shapes upside down. So if we turn this triangle upside down, is it the same? No, it is not. If we turn this square upside down, is it the same? Yes. What do you think about the trapezoid? If we turn it upside down, is it the same? You're right. No, it wouldn't be the same. And we have to draw the image. What about this funky shape with the 2 arrows? If we turn that upside down, is it the same? Yep, that one is the same. Hexagon? Yep, that's the same. Arrow? It would go the other way. No. So point symmetry is pretty easy. Turn it upside down, is it the same? The last one is rotational symmetry, and that can be a little tricky, but I'm going to give you a clue about it. We're stating all the degrees, and again we've got this like point in the middle, all the degrees that we would rotate this shape around that it would be the same. So not just 180. So how many degrees could we rotate the square or turn it and it would be the same? You're right, there's 4 different ways: 90, 180, 270, 360. Or the easier way to do it is notice that there are 4 corners and take 360 divided by 4, which is 90. So the answer is every 90 degrees. And that word every is important because we're representing 90, 180, 270, and 360. What about the triangle? How many times can we turn the triangle and it's the same? How many times can we turn the triangle and it's the same? Right, 3. And we can get that by 360 divided by 3, which is 120. So the answer is every 120 degrees. Or you can list them out: 120, 240, 360. Yep. Once you get the hang of it, it's not that bad. How many ways can I turn number 15 and it's the same? You're right, 6 different ways, right? There's 6 corners. So I take 360 divided by 6 is 60 degrees. So in this one, you might want to just answer every 60 degrees. I won't write them down, but it would be like 60, 120, 180, 240, 300, 360. Here, this next one here is just going to be, I think, those 2, or 360 divided by 2, or every 180. Or I could just say 180 and 360. How many ways for the star? 1, 2, 3, 4, 5. 360 divided by 5 is 72. So it's every 72 degrees. And again, that every is important. And what about the circle? How many times can I turn the circle and it's the same? You're right, infinite. Any number of degrees I turn the circle, it's still going to be a circle. Now this I can't really show here on the notes. We did this in class. There's a website. I put it on our website, on our page, where it's talking about words that can be read after 180 degrees rotation. So these two letters, if you actually turn your paper, you'll see the word ambigram, and when you flip your paper upside down, ambigram. Same thing with angels and demons. But let's just write down some capital letters that are the same when you flip them upside down. Go through the alphabet: A, B, C, D, E, F, G, H. Could a capital H be also an H when it's upside down? What about an I? Sure. What about a J? K, L, M, N is actually the same as I flip it upside down. It's hard to see that, but it is. O, yes. P, no. Q, no. R, no. S, yes. T, U, V, W, X, Y, Z. All those letters, if you flip them upside down, they have point symmetry, or they're the same. So that is our last section on symmetry.